Welcome to today's Automotive Tech Week 2021 session, breaking down the barriers to automotive edge adoption. It's great to have you join us here on a virtual basis. My name is Jeffrey Hanna, the Chief Commercial Officer of SBD Automotive, and I'll be your moderator for today's session. SBD Automotive is a leading automotive technology research and consulting firm. We focus exclusively on the cases technologies. So connected, autonomous, shared, electric, and security. We've been working a lot with our clients and partners on automotive edge computing, and I'm delighted that we have one of the industry's key leaders in this space, Kenichi Murata, as my special guest on today's panel. Murata-san serves as the Automotive Edge Computing Consortium President and Chairman, and is a Connected Company Fellow at Toyota Motor Corporation. Murata-san, it's great to have you here. To get started, can you please provide our audience with a little bit more about your background and really why you're so passionate about leading the AECC?
Thank you. My name is Kenichi Murata. I'm a chair of Automotive Edge Computing Consortium, and also, as you introduced me, I'm also fellow of Connected Company at Toyota Motor Corporation in Japan. And I have been working at Toyota about 30 years, and mainly in the in-vehicle infotainment systems and the telematic systems and connected car systems. And currently, I'm in charge of connected car strategies and advanced technology development, including in-car system and out-of-the-car systems, such as the vehicle big data cloud. And from my experiences of connected car development, I felt that only having the in-car technologies in my company is not enough to create new values, especially to generate values from analyzing the big data, which is generated by the connected vehicles. So I decided to create a new consortium, namely AECC Automotive Edge Computing in 2018, which is for making a good infrastructure to transmitting the kind of data in the telecom industry infrastructure and how the data is organized and managed and computed in the cloud, or so-called edge cloud. The kind of a new experiences was formed since I joined Toyota.
Absolutely. It sounds like you have a great vision and background for leading the AECC. We're going to talk a lot about sort of the benefits and technical details about automotive edge computing during our fireside chat. Really, for those viewers who are not completely familiar with the technology, maybe you can provide a quick definition of automotive edge computing and really what it means to you in the automotive industry.
Right. At AECC, we are seeing the dramatic increase in interest in connected vehicle services, which is connected vehicle makers want to consumers and global fleets everywhere to take advantage of emerging services like intelligent driving or HD mapping or mobility as a service and more. I will explain each of that kind of things later, but
Sure.
These data-intensive services are expanded to generate nearly 1,000 times more data per vehicle than today's networks and accomplished to be handled. So that the AECC was formed to solve those kinds of big volume of data challenges and help launch an exciting new connected vehicle services era. And AECC work will enable connected vehicles ecosystems to create a proof of concept and the business models to design to make driving the safer, traffic flow smoother, energy consumption more efficient, and emission lowers. And the AECC is an opportunity to make the new era of network to share knowledge with the best and the brightest from across the connected vehicle industry. And also it could be applied for the other kinds of industries, not only for the automotive industry, so that kind of, not a network of the data, but of networking the many kinds of partnership of member companies from different industries is a very good challenge to create a new area of services. And yeah, that's a kind of a definition of the consortium itself. But what is edge computing is the new challenging point.
Yeah. Well, you mentioned, this cross industry, and I agree with you, Murata-san. It's going to take really an ecosystem to bring, the vision and promise of automotive edge computing to the market. So specifically, how is the AEC and kind of yourself working together with automotive OEMs, wireless carriers, cloud providers, tech providers, to really address, the various requirements that are needed to really make this end-to-end value chain work?
Yeah, good point. Not only from the automotive OEMs experiences, we
Yeah.
are now getting in touch with much more data or software or analyzing that kind of data with AI technologies. So many variety of technology would be necessary to create a new value from that kind of environment. And the AECC bring together automotive, telecommunication, and data handling partners to develop those kinds of architecture solutions designated to process those kinds of right data at the right place and the right time to be computed. So that's what we are doing right now. And the consortium's members, including automotive OEMs and the tier ones from the auto industries and the network providers, network infrastructure suppliers, as well as networking and edge computing and cloud solution providers from the US, Europe, and Asia, China, everywhere in the world, those companies are gathering together to solve those kinds of challenges. And
Sure.
and those experts prove their ideas and the requirement from their past experiences and the system constraints together to create a toolbox that each consortium member can apply to their own edge products and its ecosystems and also product systems as well. So how we can leverage those kinds of their experiences and their past experiences to be overcome to create a new world with one more step should be discussed among those kinds of, the people who has the same destiny for the goal. So that's what we're doing. Do that, the gathering the requirement is very important things for the first step. And how we can gather the kind of the experiences of the requirement from their experiences is from the telecom point of view. They are now fighting with what kind of data usage, data patterns should be for each industry verticals, and also automotive OEMs like us is looking for the ways to handle those kind of huge amount of data collected from many different locations, and also the data managing type of IT data management companies and the cloud vendors want to see that how much volume of data, how frequently, how quickly the data should be analyzed. That kind of all the requirements, they are frustrating to see that kind of things. But if they are gathering together, we can see what kind of requirement level would be necessary to achieve their goal. So that's what we are doing. And after we gather the requirement, we can start to think about how to solve the issue. That's the first step of the consortium. And that's, having the many different variety of companies, of peoples, that's a very unique portion of the aspects of this consortium. And that's a very good efficiently generate the kind of a common senses across the industries.
That's a great answer. And so we've started with the vision, and then secondly, we talked about the importance of ecosystem and having everyone sort of in the room. And I love that you're getting all this cross-industry discussion going on. Let's back up for a minute. I want to talk for a moment about use cases. Okay, so you mentioned that edge computing has a lot of promise for end consumers, a lot of promise for governments and cities, a lot of promise for automakers. Can you, Murata-san, talk for a moment about some of those key use cases that once we have edge computing for automotive, we will really see a lot of promise in?
Right, good point. Even though that we are gathering the requirement, just that kind of requirement must be, the provided from the actual the use cases to be provided to the end customers.
Yeah.
So we are considering what kind of use cases we should primarily focusing on. And AECC and its member companies are working to bring the ecosystem together to identify the kind of connected vehicle requirements needed to be designed the next generation networks. So
Sure.
we are focusing on, firstly, we focused on the network issues so that how the network is used for those kind of new era of services. And we searched what kind of service use cases would be best fit to be analyzed. And then we identify that the one is intelligent driving, and second one is HD mapping, and the third one is the vehicle to cloud assist driving, and last one is mobility as services. In addition to that, we also added the finance and insurance services, which might be possibly implemented with the existing environment, but possibly in the future we are, leveraging the kind of a new era of infrastructure could be helping those kind of environment for the future. So that's kind of things. And for instance, the intelligent driving use cases. The cloud application will collect the data related to vehicle and the driver, and the cloud to be there to cloud, and the cloud could be analyze that kind of data. The data means the cruising data of the car, or it could be a biometric sensor data of the drivers, or it could be other types of the vehicle controlling data, such as the driving status of the vehicle status.
Yeah. Sure.
These kinds of data is then used to compute together, and what we so-called the intelligent driving parameter set. That means how the vehicle should be controlled. And that must be calculated in real time, or sometimes we so-called near real time, and feedback to the vehicles, or maybe provided to the other vehicle surrounding that particular vehicle to make a safer driving exchanges, the data. So that kind of the algorithms could be, generated from those kinds of data. But algorithm itself is the kind of a competitive portions of the kind of use cases. So without having that kind of algorithms, we just define how much data would be necessary to think about that kind of algorithms is calculated, and then that is input of the requirement. So that kind of use cases definition is now determined. And another use cases, for example, the high definition mapping. It's a HD mapping we so-called is a kind of a consolidated data of the mapping location data type of things. And sometimes we distinguish that kind of the mapping data or location data in the static data and the dynamic data. And the static data is like how the road is structured and how the road paint is painted on the road surface. And the dynamic data means how the vehicle is moving around on that particular road, or pedestrian is approaching or crossing the walk, or that kind of a dynamic information changing on the fly is a dynamic map data. and we gather that kind of things in layer by layer and
Sure.
see it together so that we can tell how the automated driving vehicle should be moving around. That kind of information is important. But to do that, we need to gather the many vehicles locations, and sometimes the other non-connected vehicle could be observed by the connected vehicle by camera or sensors. So that kind of data is also used to determine what is the situation right now on the street. So that's a kind of a new data analytics could generate more value. Once we get that kind of a dynamic map or HD map, then we can create any kinds of services which is related to location and objects, right? So that's a new type of things. The third example of the use cases we picked was the vehicle-to-cloud cruise assist. That means the vehicle's information is continuously sending to the cloud or edge cloud and analyze the condition of the vehicle and for example, the speed or how the vehicle is changing lanes or such kind of dynamic information is calculated. And then in real time or in near real time, the kind of information is analyzed together with other vehicles' information so that the vehicle can determine that kind of a feedback of the information from the edge cloud to determine which way, which direction of the automated driving vehicle should move around. So that's not only for the navigation of routing, but also lane by lane or even within the lane of the road, that kind of a vehicle can be navigated through that kind of information. So that's a vehicle to cloud to vehicle to cloud to vehicle type of real-time computation for the future. Of course, it's not really possibly achievable with the current existing technologies, but in near future, we might be able to achieve that kind of things. And it could be very much safer than just a standalone driving.
Yeah, let me jump in on that one. So you mentioned a lot of data moving around. You talked about computation. You talked about algorithms. A lot of this is really contingent upon really a next generation infrastructure in many ways. You're going to have literally hundreds of millions of vehicles competing for processing time, computations, etc. And you're going to have more centralized compute, more bigger volumes of data moving up and down through networks. Really, what are you doing within the AECC to really future-proof and prepare the foundation for these use cases with such a potentially congested environment as vehicles get connected and data is moving back and forth? Murata-san, go ahead.
Yeah, so probably you may know or you may not know that how the internet currently today is structured. The most of the use case of the internet is targeting to the downstreaming data. The big video streaming or music or video contents is streamed to many locations. And probably you may be aware that even though you connect to the cloud video streaming services, the video doesn't come from that particular cloud centralized server. Instead, the video streaming is coming from the nearest location of the cache server of the internet. And so that the overall network traffic, data traffic is saved and reduced by that kind of caching technologies. But that could be only applied to the same data to the many locations cases only. In our cases, we have to analyze the many because different data, and the data is widely spread, and that must be gathered to, if we only have a centralized cloud, we have to gather all those kinds of tons of information into one place. As you can tell, if you want to do something to bring some information to somewhere, but it's only one location, you must be in a long line of queue. For example,
Sure.
if you want to, nowadays it's not usual, but if you want to, for example, send the letter, the physical surface letter, but
Mm-hmm.
there is no post office at all, only one location, US. You have to go to there. You have
Yeah.
to go to there.
Yeah.
And when you arrive there, all the long queue will be there, right? So that the many cities, many states, many cities, many villages has many post offices, so that you can go to the nearest location of the post office to send the data. That kind of things, it could be applied for the upstreaming data cases as well
Mm.
in the network. So we would like to gather that kind of a location-dependent information to the nearest location
Sure.
and analyze the data and feedback to the vehicle. Of course, the localized data could be, handed over to this much more wider area server, and finally the global centralized location to gather that kind of information. And you can easily tell that the traffic information to be analyzed from the video camera captured camera image in the Los Angeles is nothing related to the vehicle's information running in New York City at all, right?
Right.
So
Yeah.
the information has some locality in physical location in our cases for the automotive cases. So that data should be consumed where the data is generated. Is a
Yes.
typical use cases. So we found that that kind of massive different data upstreaming should be computing somewhere in between the vehicle's location and the centralized cloud. That is the edge computing cloud.
Makes sense. So let's look into the future a little bit. Really, what's next with automotive edge computing? So really, where are we at today, and really, where are we going with this technology?
The edge technology continue to develop alongside with the 5G technologies, but it could be expanded to the automotive off-board processing opportunities. But the scope of the edge and its use of within the automotive is set to play a significant role in the vehicle functionalities. So that it's very, very important. However, the network technologies and infrastructure continues to be very important to be developed.
Mm-hmm.
And as I said, the network technology is, along with the network technology is growing up, we may be able to do more in the edge computing and edge cloud and to create more values. For example, if we can get more bandwidth, more, the short latency, we may be able to achieve much more services in real time. So that's what we are expecting the next generation, probably the 6G, 7G type of communications. But the automotive edge solution and services, that's very much we are focusing on how much services and the comfortable driving and safety driving for the future using that kind of information and data, so that that kind of the edge computing would be kind of a mandatory condition to realize that kind of things from the technical point of view. And probably if we gather much more data than we have right now, we are really struggling how to maintain the data, how longer time we should keep the data. So that kind of a data management issues will be a very big challenge for the future. And especially, as I said, the vehicle is moving across the many locations. That means the many, the edge cloud, how the data is traced, how the vehicle is traced, that means how the data is traced. If we need to analyze the data with the long historical analytics would be necessary. So that's a new challenge. And that's why, we are now how the the connected vehicle industry is processing that kind of a huge amount of data in right place, right time, and right way to manage of the data. That's a new challenging point of the edge computing. And that could be applied not only for, the edge computing is not for the automotive use cases only, but also it could be applied to the other level of the services. We
Yes.
may be able to leverage the edge cloud technologies for analyzing the massive, huge amount of data which comes from the sensors on roadside or even
Yeah.
in the houses or maybe some devices attached onto your body. So that kind of information could be, analyzed together to create more value than just automotive makers can do. So that's a new era of computing, and it's used to be, many people say that it's a ubiquitous computing or the big data handling or such kind of things. But the fact is one thing: how we can analyze analyze the data and create the new value in realistic price.
Sure. Yeah, a lot going on with data and who's going to own the data, how to analyze it, data in different places. But you've really, Murata-san, given myself and I think all of our viewers today so many innovative ideas and a lot to unpack. And for those exploring automotive edge computing, really for the first time or want to get more involved with the AECC. Murata-san, can you give your guidance on, really where to get started, how to get involved with the AECC and really come along for the ride?
Yeah. So we have a website which can be reached from the www.aecc.org, and you can look at our publications like white papers and the technical report type of things, so that you can tell the much more detail of what we have done. Which we have accomplished in the last couple of years, and then if you have much more interest to contribute something you experiences before, or even if you have a new type of the devices or technologies, then we are really welcome to join us from the website, so that you can see how you can participate AECC as a member to contribute more your ideas to create a new world or new era. But even if you are not really getting in touch with that kind of level of contribution, you can also contribute something from the participating our POC type of activities, proof of concept of the demonstration activities. And for example, in the Toyota, Ericsson's, those two companies the member of AECC, but also Vodafone is participating to those two companies to create a demonstration based on the information which the AECC published, and to make sure that they can leverage the technology we discussed in AECC. So that's a kind of a different approach to contribute something to us, to prove that we have done in the consortium, but you can also experience that new technologies. So that's another way to collaborate together with our member companies.
That sounds like a great way to get started. Full transparency, we collaborated at SBD Automotive with the AECC on a recent white paper. And if you want to read about breaking the barriers to automotive edge computing, you can read that at the AECC website or our virtual booth here at Automotive Tech Week. But I think we could talk about this, Murata-san, for hours, but sadly, I'm afraid we're out of time on today's session. We're going to have to leave it right there. I want to thank you again, Murata-san, and really congratulate you on your success, both at Toyota and having this vision for the Automotive Edge Computing Consortium. It's really making this advanced technology possible. And really a special thanks to all of our viewers today for sticking with us and going through these use cases and this vision. Really appreciate it. So thank you very much.
Thank you. Thank you very much. Bye now.
Thank you.